What's going on, class 314? This is week number 9. This is our last week of the semester. It's been a great semester, and to close it out, we are doing lab 9.1, which is the Wheatstone Bridge-Based Measurements with myDAQ and LabVIEW. First thing we have to do is constructed strain gauge configuration using a Wheatstone bridge, following the National Instruments website how-to example code. And so they give you the code on their website. They explain what the Wheatstone bridge is. From my understanding, a Wheatstone bridge is a divided bridge circuit that is used for measurement of resistance that's both static and dynamic. So this is the wire schematic that they give you that we will implement onto the hardware side of the myDAQ breadboard, consisting of a few jumper cables, some input pins to the myDAQ, as well as 3 1K resistors and 1 strain gauge that is connected to the Wheatstone bridge circuit. Over here it talks about the front panel coding strategy. So what we're basically doing in this block diagram is we're requiring the VO, Vout, and the voltage excitement, calculating that ratio, and then outputting the results, which you will see here, which is VO divided by Vx, or Vex. So on top of that, once you do implement the National Instruments block diagram, you're going to want to do a few different things for the deliverables for the actual lab. One, we are going to modify the VI to save the data to the file using Write To Spreadsheet File, which I've implemented here. Other than that, we are going to clean up the input signal by adding a low-pass filter using the Filter Express, which I have here. Filter Express. So basically, in the block diagram, we have the DAQ assistant that is getting the signal from the the load sensor, which is connected to the Wheatstone bridge circuit. From there, we're going to filter out highs, so we're going to have a low pass filter. From there, we are going to use that data and write it to a Excel file, as well as split that data into Vout, Vex or Vexcitement, and then finally the output, which is VO divided by Vex. And then from there, that data of VO-Vex is also going to be in our waveform chart, as well as written to the measurement file that is going to be Excel. So going for the demonstration, we have a pretty heavy standardized metal thingy that should put enough weight on the strain to see it in the waveform chart. So you can see as we run it, we are going to designate which path we're going to go to. Here we'll go to Instrumentation Data Acquisition, Module 9, and we will do LabVIEW Data. And once we open that, it's going to start. We can see that it's tracking VO, the excitement, and so Vout is the voltage drop, Vx is the voltage excitement, and then we have VO divided by Vex. And from here we can see that we have the waveform chart, and when we do introduce force to the strain gauge, let's see. You can see that it picks up and the amplitude is increased on the waveform chart. So that is my diagram. By measuring the resistance of the strain gauge, we can actually calculate the force and the weight of whatever is on the strain gauge. And other than that, we use these wheat bridge circuits to measure precise measurements. And these circuits, these Wheatstone bridge circuits, are usually called and referred to as the ohm meter. So that is my lab. Only other thing we have to do is locate the file in which it drew. Once we stop it, we'll go to MEC 314, Module 9. We will open the LabVIEW data. As you can see, it has written to VO, VX, VO, and VX. And these are the data values inside an Excel spreadsheet. So thank you for coming to my YouTube video. Please comment down below and subscribe. As always, thank you.